In this Dr. T's Probability Basics video, we're going to take a look at discrete probability distributions, and we're also going to create, some histograms, a way to visualize these probability distributions. Let's start with an example that we might see in some social science research. And we'll start with 150 people are surveyed, and they are asked to respond on a scale from 1 to 5. How likely are you to vote for longer sentences for people convicted of a violent crime? Beneath the question, folks are able to choose 1, not likely, 2, somewhat likely, 3, undecided, 4, very likely, and 5, extremely likely. I guess pop quiz, what type of variables are these? These responses. These are ordinal variables, right? Because the 1, 2, 3, 4, and 5 have a very clear order to them, from not likely to extremely likely. All right, so of our 150 people, we go through and count up how many folks answered 1, 2, 3, 4, or 5. And here's what we found. 24 said not likely. 33 said somewhat likely. 42 responded undecided. 30 responded very likely. And 21 responded extremely likely. Let's make sure we have all of our surveys accounted for here. I get a total going. It's another way to write total. Sum of all x. Yeah? All right, plug that into your calculator. We indeed have all 150 represented. Awesome. Now, we want to construct, and then we're going to graph using a histogram, a discrete probability distribution. The first thing we have to do, and I'm going to do this in a different kind of table, just to keep it to where it's something we're seeing, we're going to create a probability distribution table where I can put all of my x's horizontally. Then I can put the probability for each x beneath. All right, so I need the probability that someone responded with a number 1. The probability that they responded with a 1. Well, that's really not all that hard, is it? It's 24 out of the 150. That will give us 0.16 for the ones. I'll give you a few minutes to go through and fill in the rest of this table. Now, something cool about creating a probability distribution table like what we have here in green is that we can double check our work. We can make sure that we have each probability of x, or each of these scores, correct. How? Well, as you recall, or should recall, in an empirical probability, probabilities range from 0, not a chance, to 1, gonna happen. Well, all of the probabilities added together should equal to 1. So to double check, we want a sum of all probability of x. Let's go ahead and add them together. Well, if we did the probability of x correctly for each score a person could have answered, then the sum of all probabilities is equal to 1, and we got it right. Now, let's make a graphic representation of this probability distribution table. So, for a probability distribution graph, we're going to use a histogram. On our y-axis, this is going to give us a way to do the probability of x. And on our x-axis, this is where we'll have our x's. Our x's are our scores. So we had 1, 2, 3, 4, or 5. And let's see here. I'm taking a look at our probability table, and as I think of how to scale this y-axis, I think we could do it in increments of 0.05. Okay, so we'll go ahead and start with 0.05, and then the next one would be 0.10 and 0.15, and let's go all the way up to 0.30. Once we have the x and the y axes labeled, we're just going to plug in the information from our probability distribution table into the histogram. All right, so the probability that one of these 150 people who we surveyed answered they're not very likely or not likely to vote for longer sentences when someone's convicted of a violent crime is 0.16. So I'm going to go ahead and just figure, right about here. It's probably a 0.16. Pretty close, right? And I'm going to create a bar. All right. Do the same thing for those who answered a 2, which is 0.22. All right, that's probably close to here. And I'll let you do the same thing for the 3, 4, and 5 scores. Hopefully you've had a moment to fill in your histogram. This is a probability distribution histogram. And I went ahead and I labeled the different probability of x above each bar, because I could be asked a question like, what is the probability of the event that someone answered somewhat likely or undecided to this survey question? Well, if they answered somewhat likely, that was a number 2. Undecided was a 3. And if I have the scores here above my bars, well, I know that the probability that a score was 2 or 3 equal to 0.22 plus 0.28 roughly 0.50. And you can actually imagine that, right? Once you see it in a probability distribution histogram, you can see that about half of the responses were a 2 or a 3.